Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed.
On page 169, you should have the date, title, and purpose from last week's notebook setup. And then we were going to do a cone, but we're going to just do 2 boxes to start out with. So please draw this box with the side lengths 5 meters, 6 meters, and 7 meters. It's a really big box. Our goal today is to find the distance between the top point and the opposite bottom point. So we want to know the length of this diagonal right here. That's the goal. Now, from looking at this, and this was on the video from the other night, but you should be able to see a right triangle here. And if you were to rotate this and look at it from a different vantage point, you would see a right triangle that looks like this. 2 pink legs and the green diagonal. So this first vertical pink leg is the height of the box, which is 7 meters. We're trying to determine the diagonal of the box, so that's the green hypotenuse. And then we don't know what the length of this diagonal here is, or we don't know what the length of this leg is. So that's when we have to find a second right triangle. And when you look at this right triangle from the top, it looks like this. You have 2 orange legs and a pink hypotenuse. This orange leg is 6 meters, and this orange leg is 5 meters. And we need to know the pink hypotenuse. And this pink hypotenuse is the exact same answer as this pink leg up here. Once you have your right triangles, you should be able to use the Pythagorean theorem to solve for your missing side lengths pretty easily. So we're going to start with this one right here because we have 2 legs that are known and we need the C value, the hypotenuse value. So go ahead, I'm going to give you a minute to do that on your own. So I'm going to label this over here as the square root of 61. I'm not going to simplify it. I'm not going to approximate it. I'm going to leave it exactly where it is because I'm not done with working my problem yet. So now that we know all 3 sides to this triangle, that gives us our second side or our second leg to this one. Now I can find the green hypotenuse. Our side lengths are A is equal to the square root of 61 and B is equal to 7. We do the Pythagorean theorem and we substitute in. And the square root of 61 squared is just 61. I'm going to label this square root of 110. Now, I don't know about you, but whenever I say it's the square root of 110 meters, that number, I don't see what that looks like. That's hard for me to tell if that's a lot or a little. But I do know that the square root of 121, which is 11, and the square root of 100, which is 10, are pretty close to that. So I'm going to say the diagonal is approximately 11 meters. I've run out of room on my page, so add this to somewhere, I mean just on that page where you're at right now, okay? We're going to write down the steps that we take to do this, so that whenever I give you the box that's on your table and you have to find the measurements, you know exactly what you need to do, because I'm only giving you 7 minutes per box. So the first thing you're going to do is measure the sides, or measure the box. That was step 1. The second thing, and I do this because it makes sense to me, okay? But the second thing that I do is draw a picture. And then we label it. So I'm going to put draw and label a box. So all of this whole picture right here is step 2. Step 3 is to find 2 right triangles. And I did that here. That's step 3. Then for step 4, we use the Pythagorean theorem. And our A value was the length, and the B value was the width. So that's over here. And the 5th step is to use the Pythagorean theorem. Oh, there's that. Where A is your height and B is the answer from step 4. And I would say step 6 would be to approximate or simplify, depending on your directions, and write a sentence. So this is what it, that's what it looks like if you label each part of that problem. I would like for you to try one of these on your own before we start with the boxes. So somewhere, here's box B. The measurements are 1 meter, 2 meter, and 3 meters. And you can work with your tables on this, but I'm going to give you a 2-minute head start. Try to use your steps to figure out what you need to do. So here we have, we're trying to find the distance between this point and this point. Create a right triangle here. Now this one's 3 meters. And then we have to create another right triangle. So this one's going to go over here and be that one. I'm going to start with this one right here. A is 1, B is 2. Did you at least do that correctly? Start with 1 and 2. A squared plus B squared equals C squared. Then we come over here. A is 3, B is the square root of 5. Raise your hand if you got this far. Raise your hand if you're well on your way to getting this far. Okay, good. So A squared plus B squared equals C squared. 3 squared plus the square root of 5 squared equals C squared. 9 plus 5 equals C squared. 14 equals C squared. So you have the square root of 14 equals C. And we can approximate that to be between the square root of 9 and the square root of 16. So it's between 3 and 4. It's a little closer to 4. So for my sentence, I'm going to say the diagonal is approximately 4 meters.